Can you draw a line from A to the correct answer, please? So wind energy, where does wind energy go?
What?
So can you draw a line from A to the answer?
Here to no, I like here to here.
Yeah, good job, well done. So yeah, that's wind energy. How does turn yourself the right way around, please? You're upside down. How does wind energy work? How does wind energy work?
What?
How does wind energy work?
Using wind as an energy source does not produce motion. It has low.
What does the wind do?
It gives us energy.
Okay, but how? What does the wind do to the windmill?
It turns the windmill.
It turns the windmill, right? Spins the windmill, which turns a turbine inside the windmill as well. Good job. Yeah, mid A. Draw a line for solar energy, please. Yeah, cool. Good job. Well done. So solar energy, again, it's clean energy. It's really simple. It's effective. Lily, how does a solar panel work?
The solar panel collects sunlight from the sun's rays and generates electricity. And on sunny days, it will generate a lot, and it will store. So at night, then they will use it.
Cool, thank you. Michelle, I did not. Lucy, draw a line for me for C, hydroelectric. Yeah, exactly. Hydroelectric. Hydroelectric, it uses water to spin turbines, just like we saw with wind turbines. Wind, it uses powering the blades. It makes the blades move on the windmill, which turns a generator inside of the windmill, which we then use to create electricity. Hydroelectric energy does the same thing. It spins a turbine, which spins a generator, which creates electricity. So they're kind of similar in that manner, right? And let's go. Do letter D for me, please. Yeah, nice. Good job. Exactly. Geothermal energy, kind of similar to wind and kind of similar to hydroelectric. What they do is they fire water into the ground, and that creates steam. And steam then, again, spins blades, and it powers a generator, and from that we then create electricity too. All right, okay, well, it's easy, right? It's this one here. So again, it's the burning of biomass, dead organisms, things like wood. We burn it, we get the energy from that, we can then use it to create energy, create electricity, okay? So all of these things, you can see how it's done. We know that they're natural resources. It's things that are renewable, that come again and again and again, they constantly replenish. So let's go through this question number 3, please. So Lucy, what did you write for question number 3?
Renewable resources can be replenished in a certain amount of time, like trees, while non-renewable resources could be replenished very quickly. And when we use all of the non-renewable resources, they might never come back for a very long period of time.
Yeah, cool. Good job. Well done. Good answer. Minnie, what did you write?
A renewable resource can be replenished, and a non-renewable resource cannot be replenished in a reasonable amount of time.
Yeah, cool. Good job. The key word there is reasonable amount of time. In a reasonable amount of time. Well done. Rosie, what did you write?
Renewable resource can be replenished can be replenished in a certain amount of time, while non-renewable resource can't.
Good job, well done. The keyword again is replenished, to come back. They can't come back in a short enough amount of time. Pencil, what did you write for question number 3, please?
Question number 3?
Yes.
mm, renewable renewable resource is that it could be easily replaced in a short amount of time, but non-renewable resources are are they take a lot of time to form.
Yeah, cool. They take a lot of time to come back. Good job. Well done. Elsa, what did you write for question 3, please?
Renewable resource can be replenished and non-renewable resource can't.
Yeah, yeah, that's very short and sweet. Cool. Yeah, you're right. I like a bit more explanation. I don't know which. Can you put your camera on, please? Because I don't know which one to unmute. Can you tell me what you wrote for answer number 3, please?
Renewable resources can be used again and again, but non-renewable resources can use one time.
Cool. Fair enough. Good job. Okay, well done. So yeah, you've all got it right. You know this question. It's not too difficult. It's pretty easy. Renewable resources we can use again and again. Non-renewable, it doesn't work that way, unfortunately. So have a look at this page, right? So again, this is very simple. You have a wind farm, you've got a hydroelectric dam, and you've got solar panels. So, Fraser, I want you to draw a line for me for what does wind farm use to spin the blades or spin the turbine? Yeah, cool, good job. Wind power, we use wind to spin these turbines, and inside there's another generator which moves it across. Fraser, I don't need you to do any other. Thank you so much. Ming Xiao, you draw a line for me for hydroelectric power, please. Yes, thank you for doing both of them. So yes, hydroelectric power uses water instead of wind to spin the turbines. The movement of water and the flowing of water through the hydroelectric dam is the power that's used. Here we have energy from the sun, which is then collected on the solar panel, which is then turned into energy. What's the definition of energy? What do we say energy is?
Energy is like when we used something and energy is like a type of thing that is transferred from an object to and has impact on something.
Yeah, okay. Annie, you've given me the right answer. You've just given me like everything around the answer as well. Let's try to keep it simple, right? Energy is the ability to work, okay? The ability to do work. Work is exerting a force on something. So in this case, you have wind. The energy of the wind is used to do the work to spin the blade, which then creates energy. With hydroelectric power, it's the energy of the movement of water, the kinetic energy of water that is used to spin the turbine, which is then used to create electricity. And here we have energy from the sun in the form of photons, which is used to then create energy as well. So all of these cases, when we talk about renewable energy, it's work that can be done again and again. Wind does the work for you. Wind comes back, renewable. Water does the work for you. Water comes back, renewable. Sun gives you energy through photons, comes back, renewable. And that's the way I want you to think about this, right? Is when we say renewable energy, it is the ability to do work again and again and again, okay? Right? That's the way I want you to think about this going forward. Now, this question, I realized in the last class that it might be a little bit difficult for you. You might not know this, okay? You might not know the answers to these, but I'm pretty sure you told me all that there is a hydroelectric station in Huabing, yes? Yeah, cool, good job. Well, there's one example, right? Do you know any other renewable energy resource or renewable energy plants or renewable energy stations in Vietnam? Does anybody know of any? Okay, cool. I'm gonna make this part of your homework then, okay? So these pictures that I have here, right? They're both in Vietnam. They're both in the south of Vietnam. They're not in the north of Vietnam. But they are solar farms, right? They're areas in which there's large areas of solar panels to create and use solar energy. I also found this article as well. It's renewable energy for Hanoi in particular. Okay, so what it looks like is the increase in the use of solar power in Vietnam. So here you can see we have this large area of solar panels in the water. You can tell me why they think it's in the water. You know, why do you think it's in the water?
I think it is in the water because it needs to cool down if the weather is too hot.
Maybe. Maybe, maybe not. We can think of another reason. Midday.
Because there is some lands floating on top of the water.
Maybe, maybe not. I think of another reason why. Why would you put solar panels in the water? Why would you have them floating on the water? What do you think happens there? Think about what do solar panels do, right? They absorb sunlight. Why would you put solar panels somewhere like this?
So they don't cover the space, the land of the people's land and like nature.
Interesting point. Yeah, okay. Maybe they didn't want to cover nature. Jenny, what do you think?
I think because there's more sunlight.
Yeah, I would say that too. I would say, like, when you're thinking about putting solar panels somewhere, are you going to put it somewhere where it's cloudy? No, you put it somewhere where you get as much sunlight as you possibly can. And if you have a look here, right, here's some projections. So here you can see the total amount of biomass, wind, and solar power currently used in Vietnam as of 2020, as of last year. You can see it's about 6.5%. Next year, it's going to increase. And
Are they like trying to predict?
Right? They're having a guess. And this is by 2030, and you can see the amount of solar power being used in Vietnam has gone from 0.5% to 3.3%. That's a big increase. Nearly 500% increase in 10 years. That's a big increase. So what I want you to do for your homework is I want you to do some research about renewable energy sources in Vietnam, where you live, okay? You can find lots of this information here, all available to you. You can have a look and then take it from there, do some research, and on Monday we'll talk about it further. So what I'm going to do is I'm going to quickly talk about the stations themselves, right? So I'm going to look at four in particular, like wind farms. Okay, wind farms are places where you put turbines. You can put them on land or you can put them out to sea. You're going to put them in places where you can get the most amount of wind, all right? The most amount of wind. The more wind you get for the wind farm, the more energy and the more electricity you're going to be able to create. Hydroelectric power stations, they're located on rivers or they're out to sea, places where there are lots and lots of flowing water, right? I said earlier, the similarities, here we have wind spinning the turbine. In the hydroelectric station, as the water flows through, it's also going to spin another turbine. Wherever there's large amounts of water, there's lots of energy, and there's lots of energy to spin these turbines, right? Solar panels, solar farms. As you can see, they're huge areas covered in thousands and thousands and thousands of solar panels to create and absorb as much energy from the sun as possible. Hazel, where do you think a good place for a solar farm would be?
Somewhere sunny.
Yeah, like where?
The beach.
The beach. Solar panels on the beach. Okay, right. That's not a bad idea. I like the idea of solar panels on the beach. Hey, what do you think?
The North Pole.
The North Pole. That's a really good idea, and I'm pretty sure that's done. B.
Because there's it's on top, so it take many solar and it's
Yeah, no, B. You're 100% correct. Right. There's times in the North Pole when it's always in daylight. It's always sunny, right? Always sunny. Yeah, B, that's a really, really good idea. Okay, where's another place?
In the Sahara Desert.
In the desert, yeah. Desert's a really good place to have a solar farm, right? Lots of sun in the desert. Let's take that sun and create some energy. Nothing in the desert anyway.
But there is a sandstorm.
Yeah, I know there's a sandstorm, so it will be someone's job to go and clean the solar panels. after
I'm
the
not
sandstorm.
going to play.
How about a sandproof solar panel?
A sandproof solar panel. That's an interesting idea. Mid-A, if you want to go make a lot of money, that's what you need to go and do. You need to go make us some sandproof solar panels, and I think that you and me could be millionaires, right? Good idea. You and me, we can sort this out. Let's build sandproof solar panels. Let's bring solar power to the world. But yes, Dino, this one.
I think if we cover the solar panel with a layer of aerogel and then we peel off the aerogel, the solar panel will be okay because aerogel is like air. It is very thin, so it can still prevent dust, but it can still have sunlight go in it and to make energy.
You know, the only
And aerogel is not so expensive to build, to make.
So my question is, Dino, is how does it affect the absorption of the sunlight when you put aerogel on it?
Not quite, because aerogel is more than 99% air.
Okay, does it melt? Does it burn? Are
No,
you sure?
I
Find
think
out.
so.
You think? See, when you say think, I go, aha. Until you know, we don't know. Right? And the only way to do that is to test it. Okay, test it. So maybe that's what you guys should do. Go get some aerogel, get a solar panel, and let's see if we can increase absorption, and then we have a sun prevention.
Mr. Ryan, Mr. Ryan,
Yes.
Mr. Ryan, its melting point is at 1,473 Kelvin.
So that's 600.
1,200 C Celsius.
1,200. Okay, that's pretty hot.
That is really hot.
That's really hot.
Mr. Ryan.
Anyway, yes. Who asked me a question?
Me.
Okay, I don't know who me is.
Me.
I don't know. Say your name.
No.
No. All right. Okay. Fine. Well, then no more questions. Okay. Last one. Geothermal stations, right? So geothermal power stations, they're located where the Earth's crust is not that thick. Okay. It's areas where you've got active volcanoes, places like Iceland, right? They're really, really close to the Earth's core because it's pretty thin there. You can fire water into the Earth, which then creates steam. From that steam, we can get power from it. We can get the steam to spin a turbine. So we're going to look at that in a bit more detail because some of these processes are kind of the same, right? So we take wind energy. It doesn't pollute the air. It spins giant blades, and those giant blades spin a generator and a turbine, which then creates electricity. Okay. We take the idea of hydroelectric energy. Hydroelectric energy uses water energy to spin a generator, to spin a turbine. It's the same as wind energy does. It spins a turbine. The only difference is that hydroelectric uses water, wind energy uses wind. We take geothermal energy. We fire water into the earth and we create steam. The steam then rises. As the steam rises, we get it to spin a turbine. What else in history has been was steam used to run? What was steam used to move years and years ago?
Train.
Yes, thank you very much. Right, we had steam-powered trains, right? Steam-powered trains, steam-powered cars. The same idea. We used it to power, to move things. And solar energy, it's also clean energy, right? There's no pollution from it. We absorb energy from the sun. So again, those four things, right? They've got 4 things in common. They're all clean energy, right? No toxic waste, there's no pollutants into the atmosphere. With hydroelectric and geothermal and wind energy, we're using movement to move turbines. So have a look at this question. Here's 2 energy sources about the ones we've just learned about. How are the processes to produce energy the same? How are they similar? How are they different? Let's choose 2. Let's say, how are they different? Let's go, hold on. Eraser, help me here.
What?
Eraser, help me. So let's take wind energy and hydroelectric energy. How are they the same?
Me.
What?
Me.
Stop. Shh. How are they the same?
What?
How is wind energy and hydroelectric energy the same? How is the process to make electricity the same?
They come from I don't know now.
Right, B, help.
They both run through turbines.
Yes, good job, buddy. They both run through turbines. Well done.
Mr.
So again, yes, Dino.
How many is a pound?
Pardon?
How many is a pound?
In what, kilos?
Yes.
I think there's 3 pounds in a kilo. Maybe a little bit less. 4 pounds. Like Dino, we'll say, send me a message out for that one, okay? Yeah, okay, so wind power and hydroelectric, they both run through turbines, right? How are they different? Lily, how is wind power and hydroelectric power different?
You can see wind but you can see water.
Fine, okay, you can see wind, you can't see water. Well, that's very fair. So how is wind energy and water energy different in the way it makes electricity?
Please say the question again.
How is wind energy different than water energy in the way it makes electricity? What does wind energy use to create energy?
Wind energy use spinning blades.
Okay, and what spins the blades?
Generator.
No, what spins the blades? In the name, wind energy. What spins the blades? Wind, right? Okay. Honey, in hydroelectric energy, what spins the blades?
What's been what?
What spins the blades? In hydroelectric energy, what spins the blades? Honey.
In hydroelectric energy, the water flows.
Yeah, water spins the blades. So they're both the same. Wind power and hydroelectric power is that they both use turbines to create electricity. The difference is wind farms use wind, hydroelectric farms use water. Rosie, let's take geothermal energy and wind energy. How are they the same? So look what's on the page. How are they the same? Okay, Lucy, how are they the same?
They both use generator.
Yeah, they both use a generator. They both use turbines. And Virginie, how are they different?
In wind energy, the turbines are spun by wind, and in geothermal energy, the blades are spun by geothermal plants.
Yeah, cool. So by steam, right? Oh, okay, so I think you guys need to spend a bit more time on this as well, right? So your homework.
Mr. Ryan.
Yeah, 1 second, please, Dino. Let me just talk about the homework first, please. So for your homework, I want you to choose one renewable energy resource, similar to what you saw here, okay? explain about how it works. How does wind energy work? How does hydroelectric, geothermal, solar? Choose one, write about how it works, and how people are using this resource to replace fossil fuels. So you're going to need to do some research, okay? Give me some examples. Okay, give me some examples about how these are working, as well as I want you to complete question number 5 in your books. So I want you to do question number 5, and also to complete using one renewable resource and write about how it works. Does anybody have any questions about this?
Yes, Mr. Ryan. Well, we need to research about the renewable resource in Hanoi.
Yes.
Oh man, why didn't you say it?
Did yes, B question?
Teacher, what is biodiesel made of?
Biomass, right? So remember you asked the question yesterday about ethanol?
Yes.
So it will be kind of similar to that, right? So one of the things that you can make from biomass will be biodiesel, would be natural diesel.
Yeah. So, why is biodiesel? Natural diesel is non-renewable. So, what's different?
You're saying natural diesel is not renewable?
Yes.
I couldn't tell you. I don't know. I'd have to research it, B. Sorry, I don't know the answer. Yes, no.
I think if not use aerogel, we can use the compact air using a machine to make the compact air and around us like CO2. So the compact air will fire onto the solar panel and it will remove the dust.
Yeah, that's what they do at the moment, you know, they use a compressor and they spray air on it.